I can walk into any garage and tell you within 10 seconds whether the person who works in it knows what they're doing. Not by the brand of tools on the shelf, not by how new everything looks, not by how expensive the tool chest is, by 30 specific things. 30 tells that every amateur garage has and every serious garage doesn't. Some of them are about organization, some are about safety, some are about how precisely you actually work. And here's the uncomfortable part, and most of the people who have these tells have no idea they're broadcasting them. They think their garage looks fine. It doesn't. Today I'm counting down all 30, starting at number 30 and working all the way down to number 1. Number 1 is the most fundamental mistake on this list. Not the most dangerous, not the most expensive, the most fundamental, and it's the root cause of almost every other tell. And for every single one of these, I'll give you the fix. Because this isn't a roast video, it's a checklist. Go through it, fix what applies to you. Your garage will be better by the end of the weekend. Stay till the end. Let's count them down. Hard cut. Fast montage, 4 seconds. Disorganized garage, wrong tool use, cinder blocks under a car, unlabeled containers, bare concrete, dim lighting. Before we start, 3 categories. Organization tells. These are about how you store things, find things, and maintain the space. Safety tells. These are about how you protect yourself, your tools, and your work. Precision tells. These are about how accurately you actually execute the work. An amateur garage usually fails all 3 simultaneously, not because the person is careless, because nobody ever told them what the standard looks like. This video is that conversation. Let's go. Number 30, still using the blow-molded plastic cases that came with the tools. You know exactly what I'm talking about. The thin black plastic clamshell that comes inside the cardboard box. 2 plastic hinges that snap off by the 3rd opening. Foam inserts that look solid for about 6 months and then start crumbling into little black particles that you find in everything, including the motor vents of your tools. Every tool manufacturer includes these cases because they need to for shipping. They are packaging. They are not storage solutions. Here's what these cases tell me when I see them being used as primary storage. First, there's no system in this garage. If there were a system, these cases would have been replaced by something deliberate. Second, things get lost here. When everything lives in a different plastic case, the case you need is always at the bottom of the stack. And the stack falls over at least once per session. Third, tools get damaged here. Plastic cases don't protect tools from each other. That drill in the flimsy case is rolling around against other metal every time the case gets moved, and the chuck is paying the price. I worked with a guy who kept his entire socket set in the original blow-molded tray from a set he bought 12 years ago. The tray had so many cracks in it that half the sockets were held in place by friction against the broken edges. He was missing 7 sockets and didn't know it because he never had a proper inventory of what he owned. That's what happens when packaging becomes permanent storage. The fix is not expensive. A basic tool chest with foam drawer liners costs $60 to $150. You cut the foam once to fit your tools, they sit perfectly, and every time you open the drawer, you can see at a glance if anything is missing. No foam cutter? Use a marker to trace the tools, a utility knife to cut, 30 minutes of work, 10 years of better organization. Alternatively, a pegboard with labeled hooks, everything visible, everything in its place. The system doesn't matter, having a system does. Number 29 is also an organization tell, but this one is about cables. Number 29, extension cords wrapped around their own plug and shoved in a corner or coiled in a loose pile on the floor or draped over a sawhorse that's been there so long it's basically become a permanent cord storage unit. And here's what most people don't know about kinked cords. When you wrap a cord tightly around itself or fold it repeatedly in the same place, the insulation develops stress fractures at the bend points. You can't see them from the outside. The cord looks completely normal, but inside the copper strands are breaking. A cord with broken internal strands does a few things. It creates resistance at the break point, which generates heat. Heat inside an insulated cord with no ventilation is how garage fires start from what looks like absolutely nothing. It also causes voltage drop. The tool at the end of the cord runs at lower voltage than the outlet is providing, which causes the motor to work harder, run hotter, and die significantly earlier than it should. I had a shop vac motor burn out 3 years ago. Spent 45 minutes trying to figure out why. Turned out the extension cord running it had internal strand damage about 2 feet from the outlet end. The cord tested fine with a basic continuity tester. It failed under load. New cord, same vac, still running today. The over-under wrapping method solves all of this. It takes 30 seconds to coil a cord properly. The technique is on YouTube. Search over-under cable wrap. Once you know it, you'll never wrap a cord wrong again. For storage, a cord reel mounted to the wall or ceiling costs $12 to $40. It holds the cord, keeps it off the floor, and makes it easy to deploy. Every cord in the garage should have a home, a real home, not the floor. Number 28 is the floor version of the same problem. Number 28, air hose left on the floor after every job and not just left on the floor, and coiled in a loose pile in the middle of the walking path through the garage, so that every time you move between the car and the bench, you're either stepping over it or stepping on it. Here's what stepping on an air hose does over time. The outer jacket of a rubber or polyurethane hose is designed to protect the braided reinforcement layer underneath. Foot traffic wears through that jacket, especially on concrete, which is basically sandpaper for hoses. Once the outer jacket is compromised, the reinforcement layer is exposed. Once the reinforcement is exposed, the hose fails under pressure. An air hose failure at 90 pounds per square inch is not subtle. It's loud, it's sudden, and if you're near it, it's the kind of thing that sends you to get the first aid kit. Beyond the safety issue, a hose on the floor is a trip hazard. I've seen people drop tools because they caught the hose with their foot while carrying something. Small injuries, ruined parts, frustrated afternoons. The fix is a retractable hose reel, ceiling mount or wall mount depending on your setup. A decent 50-foot retractable reel costs $40 to $80. You pull it out when you need it, it retracts when you don't. The hose is always off the floor. The hose never gets stepped on. The hose lasts 10 years instead of 3. If a reel isn't in the budget right now, at minimum, hang the hose on a large wall hook after every single session. That one habit eliminates the trip hazard and extends hose life significantly. Number 27 is about what lives on your bench surface. Number 27, the workbench that hasn't had a clear surface in 6 months. I want you to picture the most cluttered workbench you've ever seen. Old cans of spray paint, a random assortment of hardware, 3 things that belong in the house but never made it back. A battery charger that's been there so long it has its own permanent spot in the dust outline. This is the bench in most amateur garages. And it's not because the people who own them are lazy, it's because the bench is the biggest flat surface in the garage, and things land on flat surfaces. Here's the real cost of the cluttered bench. Every job starts with bench clearing. Always, you need to set something down, but first you need to move something else before you can actually start working. You've spent 8 to 10 minutes reorganizing a surface that should have been clear to begin with. 8 minutes per session. If you work in the garage twice a week, that's over 13 hours a year spent clearing a bench before you can do any actual work. 13 hours gone every year. The professional approach is simple and rigid. The bench is a work surface, only a work surface. Nothing lives on the bench permanently. The bench is cleared at the end of every session. If something ends up on the bench during a job, it leaves when the job is done. The reason things pile up is that they don't have homes elsewhere. So the fix is twofold. First, add storage above and below the bench for the things that keep landing on it. A shelf above the bench for the spray cans and frequently used items, drawers or cabinets below for the hardware. Second, develop the end of session habit. Before you leave the garage, the bench gets cleared, not reorganized, cleared. A clear bench at the start of a session changes how the work feels. You walk in, the surface is ready, you put your stuff down and start. No delay, no frustration, just work. Number 26 is a precision tell that's connected to the organization problem. Number 26, multiple tape measures in the drawer, 0 calipers anywhere in the garage. The tape measure situation is itself a tell before we even get to the calipers. Why does an amateur garage have 3 tape measures? Because they keep losing them? because there's no designated home for the tape measure. It ends up in a pocket, on the bench, in the car, in the house, under something, everywhere except where it should be. So the next time a tape measure is needed and the usual one can't be found, a new one gets bought. That's an organization tell and a money tell at the same time. But the calipers issue is the precision tell. A tape measure reads to the nearest 16th of an inch on a good day. For measuring a room, cutting a board to rough length, hanging a picture, that's completely adequate. For anything mechanical or precise, checking the diameter of a bolt before buying a tap, measuring the depth of a recess to fit a part, checking if a shaft is within spec after turning. A tape measure is not the right tool. You're working to a tolerance of plus or minus a 16th when the job requires plus or minus a 1,000th. Those are not the same number. A basic set of digital calipers costs $15 to $25. They measure inside diameter, outside diameter, depth, and step measurements to a resolution of 0.01 millimeters. Every professional shop, every serious hobbyist, every watchmaker, every machinist has a set of calipers within arm's reach. The amateur garage has none because the work being done there has never required that level of precision, and it hasn't required that level of precision because the person working there doesn't know it should. Fix, buy one good tape measure, designate a hook on the bench for it, it lives there. Buy a set of digital calipers. Use them whenever tape measure tolerance isn't enough. Learn the difference between the two tools and when each applies. Number 25, another precision and organization combination tell. Number 25, drill bits stored in a pile, loose in a drawer, in a coffee can, or in the original plastic bag they came in, ripped open and re-rolled shut. I want to walk through what actually happens when drill bits live in a pile. First, they dull each other. Drill bits are hard. Hard things rubbing against other hard things causes microscopic damage to cutting edges. Every time you reach into the pile and stir it around looking for a size, every bit in that pile is getting slightly more damaged. Second, you always grab the wrong one. You need a 5/30 seconds. You grab what looks like a 5/30 seconds. You drill the hole. The bolt doesn't fit. You drill it again slightly bigger. Now the hole is too big. You've ruined the workpiece because you didn't take 3 seconds to verify the bit size before drilling. Third, you don't know what you have. A pile of bits has no inventory. If you need a 3/8 bit and the pile doesn't reveal one immediately, you might assume you don't have it and buy one, only to find 3 of them when you clean out the pile 6 months later. A drill bit index, the plastic or metal organizer with individual sized holes, costs $8 to $20 and solves every one of these problems. Every bit has a labeled home. Every size is visible at a glance. You can see instantly which sizes you have and which you're missing. You grab the right size in 3 seconds without measuring anything. For a more advanced setup, separate cases for twist bits, spade bits, and hole saws. Different tools, different storage, clearly labeled. The drill bit index is one of those purchases where you wonder how you functioned without it for so long, and it costs less than lunch. Number 24, we move into safety tells, and this one is about misusing tools. Okay. 6 down, 24 to go. I want to flag something for the back half of this countdown. Number 10 is the safety tell that I genuinely cannot explain why it's still this common in 2026. It's not a subtle risk, it's an obvious one, and it's in a significant percentage of home garages right now. Number 5 is the precision tell that affects the quality of every single mechanical job you've ever done or will ever do. It's not about a specific tool, it's about a specific discipline. Both of them are worth waiting for. Keep watching. Number 24, using a flathead screwdriver as a pry bar. Every garage has at least one screwdriver that looks like it's been through a war. Bent shaft, chipped tip, handle cracked from being struck, mushroomed over at the end from being hit with a hammer, and that screwdriver lives in the drawer with all the other screwdrivers, gets grabbed when something needs to be pried, gets grabbed when something needs to be chiseled, gets grabbed when someone needs to open a paint can. Here's what a screwdriver is actually designed for. The blade geometry is optimized for rotational force, specifically for turning fasteners. The steel is hardened to resist wear from that specific type of loading. Lateral force, prying, loads the blade in a completely different direction. The steel is not optimized for it. Under enough lateral force, a screwdriver blade doesn't bend gracefully. It snaps suddenly. with whatever energy you were applying going somewhere fast. I watched someone put a flathead in a gap under a stuck panel, lean on it, and the blade snapped. The handle end came back and hit him in the chin, not seriously, as he was fine, but it was a centimeter from his eye. Beyond the injury risk, screwdrivers used as pry bars develop bent shafts. A bent shaft means the blade doesn't seat properly in screw recesses. A blade that doesn't seat properly strips screw heads. Stripped screw heads cause much longer, much more frustrating problems. The tools that actually do prying jobs are cheap and effective. A basic pry bar, $8, comes in multiple sizes. Trim removal tools, plastic and metal, $12 for a set. These are designed for prying trim and panels without damage. Picks and hooks, $15 for getting into tight spots and separating things carefully. Every one of these does the job better than a screwdriver, costs less than a decent screwdriver, and won't send a blade fragment into your face when it fails. Fix, put a pry bar in the drawer, use it for prying, keep screwdrivers for screws, retire the war veteran flathead, it's suffered enough. Number 23 is a safety tell that takes 1 second to fix and never gets fixed. Number 23, utility knife left open on the bench. This sounds almost too simple to include, but I see it in almost every amateur garage I visit. The knife gets used, gets set down, open, on the bench surface, and then it stays there, open for minutes, sometimes for hours. Let me describe the specific risk clearly. A utility knife blade, a fresh one, will cut through skin with essentially no resistance. You don't feel a fresh utility knife cut until after it's already happened. The blade is that sharp. An open knife on a flat surface is one moment of inattention from a serious injury. Your hand brushes across the bench while you're looking somewhere else. Someone leans over the bench to reach something. A child wanders into the garage. The professional habit, and it is a habit, not a thought, is this. Every time the knife leaves your hand, the blade is closed. Not when you're done for the day. Not when you're taking a break. Every single time the knife leaves your hand. I've watched experienced woodworkers, carpenters, and fabricators close the knife as a single fluid motion, use it, set it down. It's already closed. They don't think about it. It happens automatically because they did it consciously until they didn't have to anymore. That's what habits look like. The other thing about utility knives in amateur garages, the blades are usually dull. A dull blade requires more pressure. More pressure means less control. Less control means the blade goes somewhere unintended. A sharp blade cuts with light pressure. Light pressure means control. Control means the cut goes exactly where you planned. Blade segments are scored for a reason. Snap one off, expose a fresh edge, take 2 seconds. You should never be fighting your utility knife. If you are, the blade is dull. Change it. Fix. Close the knife before it leaves your hand. Every time. Snap a fresh segment before every significant cutting session. These two habits cost nothing and prevent injuries and bad cuts. Number 22 is a safety tell that most people haven't thought about at all. Number 22, no fire extinguisher in the garage. I want to take a minute on this one because it's more serious than most things on this list. Think about what a garage actually contains. Gasoline. In vehicles and gas cans and equipment, motor oil and transmission fluid, both combustible, brake fluid, combustible, and it ignites at lower temperatures than most people think. Carburetor cleaner, brake cleaner, contact cleaner, the highly flammable aerosols. Rags soaked in any of the above. A classic spontaneous combustion risk if they're bunched up. Welding or grinding sparks near any of the above. An electrical short in a tool or charger. A garage fire can go from small and containable to uncontrollable in under 30 seconds. The difference between those two outcomes is whether there's something to fight it with immediately. A 2.5-pound ABC dry chemical extinguisher, rated for ordinary combustibles, flammable liquids, and electrical fires, costs $20 to $30 at any hardware store. It mounts on the wall near the door with a single screw. The placement matters, near the door, not in the back corner. If a fire starts between you and a back corner extinguisher, you can't get to it. Mount it where you can grab it on the way out. I've spoken to people who lost garages and everything in them to fires that started small. One described watching a rag catch from a grinder spark, trying to stamp it out, and within 45 seconds, the workbench was fully involved. No extinguisher, nothing to fight it with, $20, one screw, 1 minute of mounting. That's the entire investment. Check the pressure gauge once a year, replace it if the gauge shows it's lost pressure. That's the total ongoing cost. Fix, buy one, mount it by the door, check it annually. This is not optional safety theater. It's basic fire readiness. Number 21, the most dangerous safety tell on this entire list. Number 21, using cinder blocks as jack stands to support a vehicle. I said this is the most dangerous tell on the list. Let me explain exactly why. Cinder blocks, concrete masonry units, are designed for compressive load in wall construction. Vertical load, evenly distributed, stationary. A vehicle on a cinder block creates a completely different loading scenario. The contact point is the frame or pinch weld, a small area. Concentrated load, not distributed. Any slight shift in the vehicle, from rocking while you work, from vibration if something runs, from the ground settling, creates a lateral force component that cinder blocks cannot handle. Cinder blocks crack, not visibly from the outside initially, then suddenly completely all at once. A 3,000-pound vehicle falling 6 inches is a lot of energy. It falls faster than you can react. If any part of you is under that vehicle, you do not get a second chance. This is not a theoretical risk. People die from this. Not frequently, but it happens, and it's completely preventable. Jack stands are purpose-built for this exact load scenario. They're rated 2-ton, 3-ton, 6-ton, and those ratings are tested. A pair of 3-ton jack stands costs $25 to $40. That's the cost of one dinner out for a piece of safety equipment that you will use for 20 years. The proper procedure every time, no exceptions. Use a quality floor jack to raise the vehicle. Place jack stands at the rated lift points in the owner's manual. Lower the vehicle onto the stands. Give it a push to confirm it's stable before going under. Never get under a vehicle supported only by a floor jack. Fix. Buy jack stands. Use them every time. There is no version of this where cinder blocks are acceptable. Number 20 is a safety tell that's less dramatic but equally consistent. Number 20, no safety glasses in the garage, or, and this is just as common, safety glasses that live on a shelf and never actually get worn. Let me list what can go into your eyes in a normal garage session. Grinding, metal fragments traveling at the speed of the grinding wheel. These are not dust, these are shards. They embed in the cornea. Wire wheel work. Individual wire strands detach from the wheel at high speed. They are essentially small needles. Cutting with a circular saw or jigsaw, wood chips, splinters, sawdust. Fine sawdust is particularly problematic because it doesn't feel like much going in and causes significant inflammation hours later. Working under a vehicle, rust scale, dirt, fluids drip directly down. Your face is the lowest point. Gravity is not your friend. Compressed air work. Any contamination in the airline exits at whatever pressure you're running, often 90 pounds per square inch or more. Drilling into concrete or masonry, fine silica dust, rock fragments. The eye is not a self-cleaning, self-repairing organ. Corneal scratches and embedded particles cause permanent damage. The vision you have now is the only vision you get. The reason people don't wear safety glasses consistently is usually fit and comfort. A $3 pair from a bin hurts after 20 minutes, so they don't get worn. A $12 to $18 pair from a quality brand, DeWalt, 3M, Uvex, fits properly, doesn't fog, doesn't pinch the temples. You forget you're wearing them, which means you actually wear them. Spend the $15, get glasses that fit your face, keep them on the bench surface where they're grabbed automatically, not in the cabinet where reaching for them requires a decision. The decision is always, I'll be quick, I don't need them for this. That's when it happens. Fix, buy comfortable glasses. They live on the bench. They go on before anything spins. Number 19 is a chemical safety tell that most people don't think of as a safety issue at all. We're through 20 of 30, 10 more tells before we hit the top 10. And the top 10 are where the quality and precision issues live. The stuff that determines whether the work you do in your garage looks like it was done by someone who knows what they're doing or someone who's figuring it out as they go. Number 5 is still coming. The precision tell that affects literally every mechanical job you've ever done. 5 more away. Keep watching. Number 19, unmarked containers. Walk into the average amateur garage and look at the shelf above the bench. There will be an old water bottle with some kind of fluid in it, a spray bottle with no label or a label that's been rubbed off, a glass jar with something brown in it, a metal can with something dark inside. Nobody knows what any of these are anymore. The person who filled them might not even remember. This creates 2 distinct problems. The practical problem, you waste time. Before you can use any of these containers, you have to figure out what's in them. Smell test, viscosity check, color comparison, 5 minutes identifying containers before you can start a 10-minute job. The safety problem, you make mistakes. You think the spray bottle is water-based cleaner. It's actually solvent. You spray it on a painted surface that it immediately damages, or you use it near an ignition source that it absolutely shouldn't be near. Worse, wrong chemicals get combined. Bleach and ammonia is the textbook example. They produce chloramine vapor, which causes respiratory damage. These chemicals are both common in and around garages. If they're both in unlabeled containers, the risk of an accidental mix is real. The fix is permanent labeling. Everything in a container gets labeled before it goes on the shelf. Brand name, contents, date if relevant. A label maker costs $15. A permanent marker costs $1. Use whichever you have. Anything that can't be identified gets disposed of properly. Check your municipality for hazardous waste disposal days. Most areas have them monthly or quarterly. Don't pour mystery chemicals down a drain. Fix, label everything. Dispose of anything unidentified. Keep chemicals in original containers where possible. This takes 5 minutes and eliminates a whole category of potential problems. Number 18, we start into the precision category, and this one is about measuring. Number 18, measuring twice and cutting wrong anyway. The measure twice cut once saying has been around forever because the concept is right. But the saying assumes you know how to measure correctly. And most people in amateur garages have never been taught the 3 specific things that turn a correct measurement into a wrong cut. Error 1, marking with the side of the pencil. A standard carpenter's pencil has a rectangular lead about 3 millimeters wide. When you mark at the edge of the tape measure using the flat side of the pencil, your mark is about 1.5 millimeters wide. You've just introduced 1.5 millimeters of uncertainty into your measurement. When you cut down the middle of that mark, you're off by 0.75 millimeters on each piece. Mark with the tip of the pencil pressed right against the tape. Single dot or fine line, no width, no ambiguity. Error 2, not knowing which side of the line to cut on. After marking your measurement, you know where the cut needs to be, but the saw blade has width, the kerf. If you cut so the blade runs through the center of your mark line, you've removed half the blade width from each piece. For a 3 millimeter kerf blade, each piece is 1.5 millimeters short. The correct method, mark the waist side of the line, put a small X on the piece that's being cut off, cut so the blade runs through the waist side of the mark. The finished piece is exactly the length you measured. Error 3, incorrect use of the tape hook. The metal hook at the end of the tape measure is loose on purpose. It moves about 1/16 inch. That's deliberate. When you hook it over the end of a board, it slides out to compensate for its own thickness, giving you an accurate outside measurement. When you push it against a wall for an inside measurement, it slides in to compensate for the same thickness. If you hold the hook tightly in both positions, which most people do, every measurement is off by the hook thickness. For rough work, that's fine. For anything precise, it isn't. These 3 errors together can put your cuts 3 to 4 millimeters off spec. On a cabinet that's 600 millimeters wide, that's enough to make a drawer not fit. Fix, pencil tip only, mark the waist side, let the hook float. Practice these 3 things on scrap wood until they're automatic. Your measurements will be more accurate than they've ever been. Number 17 continues the precision theme about a specific tool most garages don't have. These 3 errors together can put your cuts 3 to 4 millimeters off spec On a cabinet that's 600 millimeters wide, that's enough to make a drawer not fit. Fix, pencil tip only, mark the waist side, let the hook float. Practice these 3 things on scrap wood until they're automatic. Your measurements will be more accurate than they've ever been. Number 17 continues the precision theme about a specific tool most garages don't have. Number 17, no reliable square anywhere in the garage. This is one of the most consequential precision gaps in an amateur garage. A square doesn't just check if something is 90 degrees, it propagates accuracy through a project. When you use a square to set up a fence, every cut off that fence is square. When you use a square to check a box during glue up, every joint in that box closes correctly. When you use a square to set the blade angle on a miter saw, every compound cut is accurate. Without a reliable square, every one of these steps relies on feel and eye compound errors. A shelf that's 1 degree off horizontal looks fine when it's empty. Put books on it and every book slowly slides to one end. A box that's 1 degree out of square doesn't look wrong until you try to fit a lid. A miter joint that's half a degree off closes with a visible gap. Here's the important word I've been using: reliable, not just any square. A $4 plastic speed square from a bin is often not actually 90 degrees. The plastic mold shrinks as it cures. The resulting tool can be off by a degree or more. A degree sounds like nothing. In a 24-inch square, 1 degree of error is 4 millimeters at the far end. That's a visible gap. Test any square before you trust it. Hold it against a straight edge. Draw a line, flip the square, draw another line from the same starting point. If the 2 lines are parallel, the square is accurate. If they diverge, it's not. A speed square that passes this test is fine for most work, $8. A combination square, sliding blade, locking nut, 45-degree face, built-in scribe, passes this test and does more, $25 to $45 from Empire or General Tools. Fix, own at least 1 tested reliable square. Test it when you buy it. Test it annually. Use it before committing to any joint or cut. Number 16 is about the physical setup of your workspace. Number 16, using the car hood as a workbench, or the car roof, or the car trunk lid, or a piece of plywood balanced on top of the tool chest, or literally the floor. This is one of those tells where I don't even need to see the garage. If someone tells me they set parts on the hood while they work, I already know a lot about how that garage operates. Here's the specific problem with the hood as a work surface. Height. A car hood is at bumper height, roughly 24 to 30 inches depending on the vehicle. That's below kitchen counter height. Working at that surface means you're bent forward with a curved back. After an hour, your lower back is telling you about it. After 4 hours, you're not finishing the job today. Proper workbench height, 34 to 36 inches, keeps your back neutral. That's not comfort, that's hours of productive work versus a shortened session. Stability. A hood is not a rigid surface. It flexes, parts placed on it can move, parts can fall off. A bolt that rolls off a hood onto a concrete floor can go anywhere within a 10-foot radius. If it goes into the engine bay, you may or may not find it before you start the engine. Paint. Every tool placed on a hood scratches it. Every fastener set on a fender scuffs it. Even with a fender cover, in which most amateur garages don't have, you're accepting that the car's finish is a work surface. A dedicated workbench doesn't have to be expensive or permanent. A solid core interior door, available at salvage shops for $10 to $20, laid across 2 metal sawhorses at the right height, gives you a full-length, rigid, flat work surface that doesn't care what you do to it. Total cost, $40 to $60. If you want something more permanent, a 2x4 framed bench with a plywood top can be built in an afternoon for about $80 in materials and lasts indefinitely. Fix, build, or buy a dedicated work surface at the right height. Keep parts and tools off the car. Your back will recover. The car's paint might not. Number 15, this is the precision tell that separates a lot of amateur work from professional work. Number 15, eyeballing everything. The shelf that goes up without a level, the hole that gets drilled without checking the angle, the joint that gets set without checking for square, the fence that gets clamped without measuring from the blade. Every one of these is a decision to rely on instinct when a $15 tool would remove the instinct from the equation entirely. Here's why professionals don't eyeball things. It's not that they have better eyes. It's that they know exactly how wrong a confident eye can be. The human visual system is incredibly good at detecting differences between two adjacent things. Is the left side higher than the right? And it's very bad at absolute measurements. Is this exactly level? A shelf that looks perfectly level when you step back and squint can be 2 degrees off. 2 degrees over a 6-foot shelf is about 4 inches of drop. You'd notice that if someone told you the number, but your eye says it looks fine, so you go with the eye. The specific tools that remove eyeballing from the equation: a torpedo level, $10, 3 inches long, fits in a pocket, tells you if something is level, plumb, or at 45 degrees. Use it every time you mount anything to a wall. A combination square, $30, already mentioned. Use it for every joint and angle setup. A digital angle gauge, $20. Magnetic base. Sticks to metal surfaces. Reads angle to 1 decimal degree. Set your table saw blade angle with this, and it's perfect every time. Not close, perfect. A straight edge. A quality aluminum one, $20 for 36 inches, tells you if a surface is flat or if a fence is parallel. These 4 tools cost $80 total. They eliminate eyeballing from 95% of layout and setup work in a garage. Every cut is more accurate, every joint fits better. Every surface is level. The time investment, 5 seconds per measurement. The accuracy improvement, from plus or minus a degree or two to plus or minus a fraction of a degree. Fix, buy the measurement tools, use them every time. The results will be immediately and obviously better. Number 14. An organization tell about what happens after the work. Number 14, no system for cleanup during or after work, the shop that never gets cleaned. Metal shavings distributed across the floor from the last 3 projects. A growing pile of sawdust under the bench that's been there since spring. Oil stains on the concrete that have been there long enough to have absorbed multiple layers of subsequent contamination. Beyond the obvious, it looks like nobody takes the work seriously. There are 3 specific practical problems with an unclean shop. Problem 1, metal shavings, steel and cast iron shavings from grinding, cutting, and drilling work their way into shoe soles and get tracked out of the garage into the rest of your life. They also migrate into places they shouldn't be, into finished project surfaces, into tool storage, potentially into moving parts of equipment. Steel shavings in a drill press or lathe cause rapid wear. Problem 2, sawdust combustion. Fine wood dust, the kind produced by sanders and table saws, has a lower ignition temperature than you'd expect. A significant pile of fine sawdust near an ignition source is a real fire risk, not theoretical. Real. Professional wood shops have dust collection systems specifically because the liability and safety risk of accumulated fine dust is well understood. Problem 3, oil on concrete. Concrete is porous. Oil seeps in immediately on contact. Old oil stains are nearly impossible to fully remove. Fresh oil stains in a high-traffic area become slip hazards, especially when the garage floor gets wet or dusty. The cleanup system doesn't need to be elaborate. A shop vac, $40 to $60. Run it for 5 minutes at the end of every session. Metal shavings get swept into a pile and disposed of in a sealed container. Oil spills get covered with absorbent. Cat litter works fine. Left for an hour, swept up, wiped with a rag. Clean as you go during long sessions. If you drill a series of holes, vacuum the area before moving to the next operation. If you cut metal, sweep the shavings before changing tasks. The psychological effect of a clean shop is also real. A clean bench and clean floor makes you more careful. It raises the standard of the work unconsciously. Mess breeds carelessness. Order breeds precision. Fix, get a shop vac. Use it every session. Clean spills immediately. The total time cost is 5 to 10 minutes per session. Number 13. This one is about how you maintain what you already own. Number 13. Rust on hand tools and cutting tools. Surface rust on the body of a wrench. Minor. It looks bad but doesn't affect function much. But rust on cutting tools is a different problem entirely. A chisel with a rusted bevel has a damaged cutting edge. The rust isn't just discoloration, it's material loss. The edge geometry is compromised. You can sharpen it back, but you're removing more metal than a clean chisel needs. A rusted saw blade has pitted teeth. Pitted teeth catch instead of cut. They tear fibers instead of severing them. The cut quality is poor, and the blade requires much more force to push through. A rusted plane iron is unusable until it's been flattened and sharpened back. That's 30 minutes of work that wouldn't be needed if the tool had been wiped with oil before storage. Here's what rust tells me about a garage. It tells me that the tools aren't maintained. And tools that aren't maintained are tools being used in a degraded state. Work done with degraded tools produces results that reflect the tool's condition. Bad edges, poor fits, more effort for worse outcome. The physics of rust in garages, concrete floors emit moisture, temperature swings cause condensation on metal surfaces. A garage that goes from cold night to warm day is cycling metal surfaces through moisture exposure constantly. The prevention is simple. After any session where tools have been handled, especially metal hand tools, wipe them with a cloth that has a small amount of oil on it. Any thin oil works. Machine oil, camellia oil, 3-in-1 takes 30 seconds per tool. For longer storage, a light coat of paste wax on tool surfaces. Wax is more durable than oil and doesn't attract dust the same way. For storage environment, silica gel packets in drawers absorb ambient moisture. A bag of 50 packets costs $8 and lasts a year. Replace them annually. A rust inhibitor spray, BoShield T9, is the standard recommendation and provides a protective coating on metal surfaces that's more durable than oil. Use it on saw blades, plane irons, and chisels at the end of every season. Fix: wipe tools with oil after use. Store cutting tools with rust protection. Use silica packets in drawers. Sharpen anything that develops surface rust before it worsens. Number 12, directly connected to this, about dull cutting tools. 13 down, 17 to go. We're entering the top 15 now. This is where the precision tells get specific. The details that separate work that holds up under inspection from work that reveals its compromises when you look closely. Number 5 is 3 away. I keep mentioning it because it genuinely is that important. Every torque spec you've ever guessed at, every fastener you've tightened until it felt right. We're going to talk about what that actually means for the longevity of your work. 3 more. Keep watching. Keep number 12. Using dull cutting tools and treating the difficulty as normal. This is one of the most pervasive quality problems in amateur garages and one of the least recognized, because if you've never used a sharp tool, you don't know what you're missing. Let me describe what a sharp chisel feels like on wood. You place it on the surface with the bevel down, you push with your thumb, it moves without a mallet, just thumb pressure. The wood fiber separates cleanly. No tearing, no crushing. The cut surface is smooth. That's a sharp chisel. Now the dull version, you place it, you push with your thumb, nothing happens. You get the mallet, you strike. The chisel moves a few millimeters. The wood compresses and tears at the same time. The cut surface is rough and ragged. The chisel wanders offline slightly because it's deflecting off the wood fibers instead of cutting them. All of that extra force, the mallet, the effort, the pushing, goes somewhere when the tool doesn't cut cleanly. Sometimes it goes into the workpiece in the wrong direction. Sometimes it goes into the bench. Sometimes it goes into whatever your other hand is holding. A sharp cutting tool removes material with control. A dull cutting tool requires force. Force is the enemy of control. The same principle applies to every cutting tool. Plane irons, saw blades, router bits, drill bits. A sharp tool makes the work easier, more accurate, and safer. A dull tool makes it harder, less accurate, and more dangerous. Sharpening is a skill. Like any skill, it improves with practice, but the basics are learnable in an afternoon. For chisels and plane irons, a combination Waterstone 1000/6000 grit costs $25. A honing guide holds the tool at a consistent angle, costs $12. Together they will get any edge to shaving sharp in 10 to 15 minutes. For saw blades, most circular saw and jigsaw blades are not worth sharpening. Replace them when they're dull. A quality blade costs $15 to $30 and will outlast 3 cheap blades. For drill bits, a drill bit sharpener costs $20 to $30 and works well on twist bits. Or learn to sharpen by hand on a bench grinder. It takes 20 minutes to learn and you can sharpen a bit in 60 seconds once you know it. Fix: buy a sharpening stone. Learn to hone a chisel. Recognize when saw blades and drill bits need replacement. Work with sharp tools and notice the difference immediately. Number 11 is about the environment your tools work in. Number 11, working in a dim or poorly lit garage. The standard garage ceiling fixture, 2 or 4 fluorescent tubes in a plastic housing, produces somewhere between 2,500 and 4,000 lumens. For a 2-car garage of roughly 400 square feet, you need 8,000 to 12,000 lumens for adequate task lighting. Most garages are running at 1/3 to half the light they need. Here's what insufficient light costs you in practical terms. Safety. You don't see the thing on the floor until you've tripped on it. You don't see the fluid leak that tells you something is wrong before you run the engine. You don't see the hairline crack in the part. Precision, your eyes work harder in dim light. They fatigue faster. Fatigue means less accurate perception of what you're looking at. Gaps that should be caught get missed. Measurements are harder to read. Over a long session in dim light, the quality of the work at hour 4 is noticeably worse than at hour 1. Not because you're tired, but because your eyes are compensating for bad lighting. Diagnosis, finding the source of a noise, a leak, a crack. All of this requires being able to see clearly into tight spaces. A dim garage with no supplemental lighting makes every diagnostic task harder. The upgrade is not expensive. 2 5,000 lumen LED shop lights, the kind that plug into a standard outlet and mount to the ceiling with hooks, cost $30 to $50 each. 2 of them in a 1-car garage doubles your light output immediately. For a 2-car garage, 4 of them gets you to professional shop levels. Color temperature matters too. 5,000 Kelvin to 6,500 Kelvin, daylight to cool white, is best for seeing colors accurately. This matters when you're matching paint, reading color-coded wiring, or trying to see the difference between 2 similar fluids. Supplement the overhead with task lighting for specific work areas. A flexible armwork light on the bench, a magnetic inspection light for engine bays, a headlamp for working under vehicles where no overhead reaches. Fix, add LED shop lights. Calculate lumens for your space. Add supplemental task lighting for detail work. Good lighting is one of the highest impact, lowest cost garage upgrades possible. Number 10, the one I mentioned at the very beginning of the countdown. Number 10, no first aid kit in the garage. I flagged this one early because it's surprisingly common and surprisingly easy to fix. Think about the specific injuries that happen in garages. Cuts from utility knives, sheet metal edges, grinding sparks, sharp fasteners, burns from hot metal, exhaust components, welding, brake fluid on skin, eye irritation and from dust, solvents, chemical splash, punctures from drilling, nails, sharp objects, abrasions from concrete contact, wire wheel fragments, chemical contact, from brake cleaner, penetrating oil, carburetor cleaner. Every one of these is a minor incident if treated immediately. Every one of them becomes a more significant problem if the nearest first aid supplies are in the house and you have to walk inside, find where they are, and come back. And in the time it takes to do that, you've bled on several things, touched other things with contaminated hands, and the minor cut has become a minor cut plus a frustrating cleanup job. A basic garage first aid kit contains adhesive bandages in multiple sizes, sterile gauze pads and medical tape, antiseptic wipes and wound closure strips, eye wash solution, specific to chemical splash, not just water, tweezers for splinters and embedded metal fragments, burn treatment gel or dressing, nitrile gloves so you can treat someone else without contamination. A pre-assembled kit with all of this costs $15 to $25. Mounted on the wall near the door, same logic as the fire extinguisher, near the exit, accessible, visible, check it annually, restock anything used. A bandage used and not replaced means the next cut gets treated with creative solutions. This is so simple, it takes one purchase and one mounting screw. The garage that has a first aid kit is the garage where safety is taken seriously. Fix, buy one, mount it by the door, check it once a year. Number 9, the labeling tell. Number 9, no labeled storage anywhere in the garage. You know where everything is. You'll tell me that with confidence, and you're right. right now in this moment you do know, but you know the way you know where your phone charger is approximately based on recent memory, subject to revision anytime someone else touches something or you have a slightly different session than usual. Here's what unlabeled storage actually costs in a professional context. Cognitive load: every unlabeled drawer is a question. Is the 10mm socket in this drawer or the one below it? Where did I put the carburetor cleaner? Which bin has the M8 bolts? These questions seem trivial individually. Over a 4-hour session, you ask variations of them 15 to 20 times. Each one is a small interruption. You stop what you're doing, go look, come back, re-engage with the task. That's cognitive switching cost. It adds up. Studies on professional work environments, not garages specifically, but applicable, show that interruptions of this type, even very short ones, extend total task time by 20 to 30%. For a 4-hour garage session, that's 48 to 72 minutes of lost time every session from not having labels. The more important problem: you install the wrong thing. You reach into the unlabeled fastener drawer for an M8 by 1.25 bolt. You find something that looks right in dim light. It's an M8 by 1. Oh, same diameter, different thread pitch. It goes in with slight resistance, which you attribute to thread condition. It's not, it's cross-threading. You've damaged both the bolt and potentially the threaded insert or nut. A label maker costs $15. Masking tape and a marker costs $2. 1 hour of labeling every drawer, shelf, and bin in the garage. The return on that 1 hour of investment every session after that is faster. Every search is replaced by a direct retrieval. Every component goes into the right place because it has a right place. Fix: label everything. Do it this weekend. 1 hour of work. The dividend pays every single time you work in the garage after that. Number 8, a lighting precision tell that's separate from general overhead lighting. Number 8, relying entirely on overhead lighting for detail work. We covered general shop lighting at number 11. This is a different and more specific problem. Overhead lights illuminate horizontal surfaces from above. They create shadows in exactly the places you most need to see. Inside an engine bay, the overhead is at the wrong angle. Everything in the bay is in shadow unless your shop lights are directly above and the hood is open at exactly the right angle. Under a dashboard, completely in shadow. In a cabinet carcass during assembly, the overhead hits the top panel, casting everything inside into shadow. In a hole you've just drilled, dark. In the gap between two components you're trying to align, dark. Shadows are where mistakes live. You can't see the gap you're not fitting. You can't see the wire you're about to pinch. You can't see the cross-threaded fastener starting to go wrong. Professionals use multiple light sources. The overhead sets the general level. Supplemental lights go to where the work actually is. A flexible gooseneck work light on the bench, $15 to $30. You bend it to point directly at whatever you're working on. The shadow goes behind the work, not on it. A magnetic base inspection light, $20. It sticks to any metal surface and stays where you put it. In an engine bay, on a cabinet side, on the underside of a shelf, a quality headlamp, $12 to $25. Your light source moves with your head. Wherever you look is illuminated. Under cars, in tight spaces, anywhere the other lights don't reach. These 3 tools together cover every lighting scenario in a garage. Total cost, $50 to $75. Fix: own all 3. Use them whenever the overhead creates shadows on your work. That's most detail work every time. Number 7, about how you approach fasteners. Number 7, using the wrong size tool on fasteners and rounding them, the rounded bolt head, the stripped screw drive, the fastener that now requires an extractor to remove. Every one of these is caused by the same underlying mistake, a tool that almost fits being used as if it fits perfectly. An 11mm socket on a 10mm bolt. It goes on, it seems to grip. Under torque, the socket corners contact the bolt flats at the wrong geometry. The corners of the bolt round off under the load. Now you have a fastener that nothing grips properly. A Phillips bit in a JIS screw. JIS, Japanese Industrial Standard, is common on Japanese vehicles. It looks identical to Phillips. It is not identical to Phillips. The cross angles are slightly different. A Phillips bit in a JIS recess cams out under torque and damages both the bit and the screw recess. A metric wrench on an SAE bolt, or vice versa, close enough in size to go on, not right. The flats don't match. Under torque, the corners round. The fastener is damaged. The time cost of a rounded fastener is substantial. Best case, you can get an extractor socket on it. That's 15 minutes and a trip to the parts store. Worst case, you're drilling it out or welding a nut on. That's an hour or more depending on accessibility. The prevention is completely trivial. Before applying torque to any fastener, verify that the tool fits with zero play. A correctly fitting socket has no rocking movement on the bolt head. A correctly fitting bit seats fully into the drive recess with no gap. If there's play, stop. Find the right size. It's always worth the 60 seconds. For JIS screws specifically, buy a JIS screwdriver set, $15 to $20. Every Japanese vehicle owner should have one. The difference between a JIS driver and a Phillips driver in a JIS screw is the difference between a fastener that comes out and one that doesn't. Fix, verify fit before applying force. Zero play means correct size. Any play means find the right tool. Keep a JIS set if you work on Japanese vehicles. Number 6, the floor tell. Number 6, bare concrete floor with no mat, no coating, no protection of any kind. Let me break this into the 3 separate problems bare concrete creates. Problem 1, porosity. Concrete is porous at a microscopic level. Fluids, oil, coolant, brake fluid, transmission fluid penetrate the surface within seconds of contact. Once absorbed, they are nearly impossible to fully remove. You can clean the surface, you cannot clean the concrete. Over years, a bare concrete garage floor becomes saturated with hydrocarbons. This has 2 effects. First, any new spill immediately has old contamination to mix with, making cleanup chemistry more complex. Second, the absorbed hydrocarbons can leach back out under certain temperature conditions, creating a perpetually damp, slippery surface that smells like an old gas station. Problem 2, thermal mass and joint fatigue. Concrete conducts cold efficiently. Standing on a cold concrete floor for 4 hours draws heat from your body through your feet, through your legs, and into your lower back. That's not perception, it's thermodynamics. The result is fatigue, joint stiffness, and a shortened productive session. This is not a comfort complaint, it's a productivity issue. An hour less of productive work per session over 50 sessions a year is 50 hours. Anti-fatigue mats interrupt the thermal connection. The foam layer acts as insulation. Your feet stay warm, your back stays loose. You work longer and better. Problem 3, surface hardness and dropped parts. A socket dropped on concrete bounces in a random direction. A glass bottle dropped on concrete breaks. A precision part dropped on concrete can be damaged on impact. Interlocking rubber floor tiles, $1 to $3 per square foot, provide cushion for dropped items, thermal insulation, and a surface that can be cleaned properly. Epoxy floor coating, $100 to $150 for a one-car garage, seals the concrete, creates a cleanable surface, and eliminates the porosity problem entirely. Minimum viable fix, an anti-fatigue mat in your primary work area, $20 to $40. The difference is immediate and significant. Complete fix, interlocking tiles or epoxy coating for the full floor, $150 to $300 for a one-car garage. Lasts 15 to 20 years. Your body will tell you about the mat within the first session. Number 5, the one I've been building toward. Number 5, no torque discipline. This is the precision tell that affects the longevity of every mechanical job you've ever done in a garage, not the appearance of the work, the durability of it. Torque specifications are not suggestions. They are engineering calculations based on the specific fastener material, the specific thread engagement, the specific clamping force required, and the specific load the assembly will experience in service. Every vehicle manufacturer publishes these specifications. Every fastener application in every service manual has a torque value. They are freely available online for every make and model. They are not secret. They are not difficult to find. And most amateur mechanics ignore them entirely. They tighten until it feels right, until it feels tight, until it feels like it won't come loose. Here's the problem with that. The feel of a fastener tightening varies with the thread condition, the lubrication state, the material of the component being fastened, the length of the wrench being used, how tired your arm is, and how tightly you're gripping the wrench. None of those variables are calibrated. The feeling of tight is not a repeatable measurement. It is a different measurement every time, performed by a different instrument, your arm in a different condition. Under-torqued fasteners come loose, not immediately usually. Under vibration and thermal cycling over time. A wheel lug nut that's hand tight plus a quarter turn feels solid when you first drive. After 100 miles of road vibration, it's backed off noticeably. A cylinder head bolt that's short of spec by 15 foot-pounds may hold for 6 months before a coolant leak begins. Over-torqued fasteners fail in the other direction. Aluminum engine components are particularly vulnerable. Spark plugs threaded into aluminum heads, over-torqued. Strip the threads out of the head. Repair cost, $200 to $500. Oil drain plugs over-torqued into aluminum pans. Stripped threads. Repair cost, $80 to $300 depending on the repair method. Wheel studs over-torqued with an impact gun. They stretch, weaken, and can fail at highway speed. The tool that eliminates this entire category of error is a torque wrench, a calibrated, accurate torque wrench, and the practice of looking up the specification before tightening. A mid-range torque wrench, CDI, Tecton Proto, costs $40 to $80. Get it calibrated annually. Cost $20 to $40. The discipline, look up the torque spec every time. It takes 30 seconds. Set the wrench to the spec. Tighten until the wrench clicks. Stop. Do not continue tightening after the click. Do not add a little extra because the click didn't feel tight enough. The click is the spec. Trust the spec. Stop at the click. This single practice change, using a torque wrench on every critical fastener, will make every mechanical job you do more reliable and will prevent a category of failure that is otherwise unpredictable. Fix, buy a quality torquey wrench. Calibrate it annually. Look up every specification. Stop at the click. 4 left. These are the 4 tells that I see in almost every amateur garage. Top 4. We've covered organization, we've covered safety, we've covered precision. These last 4 cut across all 3 categories. They're the tells that make a professional wince when they walk into an amateur garage. Let's finish the countdown. Number 4, improvise personal protective equipment, sunglasses instead of safety glasses, a bandana or a t-shirt pulled up over the nose instead of a proper dust mask, dish gloves instead of chemical-resistant gloves, kitchen oven mitts near a welding operation, no hearing protection on a long grinding or routing session. I understand the thinking completely. The right thing is somewhere, in the cabinet, in the bag, in the house, and this job is going to be quick, and the improvised thing is right here. Here's the specific problem with each of these substitutions. Sunglasses instead of safety glasses. Sunglass lenses are made to block UV light and look good. They are not impact rated. The ANSIZ 87.1 standard that certified safety glasses meet involves testing with specific projectiles at specific velocities. Sunglass lenses are not tested to this standard. A metal fragment that a rated safety lens deflects will go through a sunglass lens. Bandana instead of an N95 mask. An N95 mask filters 95% of particles 0.3 microns and larger. A folded bandana filters some of the larger particles and essentially none of the fine silica dust, fine wood dust, or respirable metal dust that causes long-term lung damage. The protection feels similar. The actual filtration is not comparable. Dish gloves with solvents, latex and thin vinyl. The materials in dish gloves dissolve in acetone, methyl ethyl ketone, and many other solvents. The glove material doesn't protect, it concentrates the chemical against your skin. Chemical-resistant gloves, nitrile for most solvents, neoprene for stronger chemicals, are made from materials that resist permeation. Different tool, different protection level. The correct PPE for a complete garage setup. Safety glasses rated ANSIZ 87.1, $12 to $18. N95 masks, box of 20, $15. Chemical resistant nitrile gloves, box of 50, $12. Ear protection, foam plugs or earmuffs, rated NR R25 or higher, $5 to $20. Total under $60. Permanent solution, keep it on the bench. all of it right there. Grab it before the work starts. The improvised version gives you the feeling of protection without the reality. That's worse than nothing because it removes the discomfort that would otherwise make you go get the right thing. Fix, buy real PPE, keep it accessible, use it every time. Number 3, the finishing tell. Number 3, no deburring done on cut metal edges. This one is about craft, and craft is the difference between work that's done and work that's finished. When you cut metal, pipe, bar stock, sheet metal, angle iron, the cutting process displaces material at the cut edge. This displaced material forms a burr, a thin, sharp ridge of metal projecting from the cut face. You can feel it with the fingernail if you run it across the cut edge. Sometimes you can see it, sometimes it's too fine to see, but not too fine to cut you when you handle the part. An amateur installs the part with the burr. The burr then does one of several things over time. It cuts through any gasket or seal it contacts. It wears into any hose or wiring harness it touches. It draws blood from the next person who handles the part without knowing it's there. A deburring tool costs $6 to $12. It's a small handheld tool with a rotating cutting head that removes the burr in a single pass around the edge. 5 seconds per cut edge. No skill required. Alternatively, a flat file removes burrs from straight edges in 15 seconds. A countersink bit removes burrs from drilled holes. Fine sandpaper or a Scotch-Brite pad removes burrs from sheet metal edges. Professional fabricators deburr everything automatically. The part isn't done until the edges are clean. Here's why this goes at number 3 instead of lower. It's not just a safety issue, though it is that. It's a tell about how much you care about the finished quality of your work. A deburring tool on the bench used consistently tells me the person working in this garage does complete work. No deburring tool, parts installed with burrs still on them, tells me the work is done when it's done, not when it's finished. That distinction matters. Fix, buy a deburring tool. Use it on every cut metal edge before the part goes in. It takes 5 seconds and it's the difference between done and finished. Number 2, the fastener organization tell. Number 2, the junk drawer of mixed fasteners. Every garage has one. Some garages have several. The coffee can from 3 years ago. The shallow drawer that everything falls into. The plastic bag from a flat pack furniture build that somehow migrated to the garage. Inside, screws of 15 different sizes, bolts metric and SAE mixed together, nuts that may or may not match any bolt in existence, washers of ambiguous size, mystery hardware from unknown origins, fasteners with damaged threads, rusty ones, bent ones, and somewhere in there the specific M6x20 bolt you need right now that you know must be in there somewhere because you definitely saved some from that project 2 years ago. You spend 12 minutes going through the can. You find something that looks right. It's an M6x25. You install it anyway because it's close and you have it. Here's what just happened. You installed a fastener that's 5 millimeters too long. Depending on the application, that 5 millimeters bottoms out in a blind hole before the fastener clamps the joint, meaning the joint isn't clamped, or it protrudes on the other side and interferes with something, or it's fine and you got lucky. The junk drawer doesn't let you know which scenario you're in. That's the problem. A proper fastener organization system, divided bins, the kind you hang on a pegboard or mount on a shelf, sorted by type and size, machine screws, wood screws, sheet metal screws, metric and SAE bolts by size, nuts sorted to match, washers separated by size. This system costs $15 to $30 for the bins. Setting it up takes an hour. And sort the junk can. Throw out anything rusty or damaged. Buy new fasteners for the sizes you use regularly and don't have clean examples of. After that hour, every fastener retrieval takes 30 seconds instead of 10 minutes. You install the correct fastener every time because you know exactly what you have. You know immediately when you're low on a size because you can see the bin. You stop cross-threading fasteners because you're installing the right size, not something that seems close. Fix, sort, organize, label, throw out anything compromised. buy fresh stock in the sizes you use most. Never dig through the can again. Number one, the one that every other tell on this list traces back to. Number one on this countdown, and it's not a tool, it's not a piece of equipment, it's not something you can buy. It's the absence of a system, the absence of a process, the absence of a standard for how work gets done in the garage. Let me describe what I mean precisely. A professional, any professional in any craft, has a set of practices that they follow consistently, regardless of how they feel, regardless of how short the job is, regardless of how routine it seems. Before the grinder starts, the glasses go on. Before the car comes off the jack, the stands go in. Before the fastener gets tightened, the spec gets looked up. Before the tool goes back, it gets wiped down. Before the session ends, the bench gets cleared. These practices are not decisions. They were decisions once, a long time ago. Now they are habits, automatic. They happen without deliberation. The amateur garage runs on improvisation. This job is short. The glasses aren't necessary. I've done this enough times that I know roughly how tight it should be. I'll clean up next time. I'll find a home for that later. That improvisation is the root cause of almost every other tell on this list. The extension cord wrapped wrong, no system for cord storage. The workbench buried in clutter, no system for end of session cleanup. The rusted tools, no system for post-use maintenance. The unlabeled containers, no system for chemical organization. The junk drawer of fasteners, no system for hardware storage. Every single one of these traces back to the same origin. Nothing has a defined right way to be done, so everything gets done however it gets done in the moment, and the moment is always a compromise. Quick, convenient, good enough. The professional standard is different. The professional standard says the work matters enough to do it the same right way every time, not because you feel like it today, because that's what the standard requires. How do you build this? You start with one practice, pick the most important one, probably the safety glasses, probably the Torca wrench, probably the end of session cleanup. Just one. Do it consistently for 30 days. Not because you remember, set a physical reminder. Glasses on the bench, not the shelf. Wrench on the hook beside the car, not in the drawer. Do the one thing until you don't have to decide to do it anymore. Then add another. This is not about making your garage look good. It's about raising the standard of what comes out of your garage. The work you do reflects the environment and the process you do it in. A garage with a system produces consistent, reliable, high-quality results. A garage without one produces results that vary with the mood of the afternoon. That's number one, not a tool, a standard. Set one, raise it, everything else follows. Pick the most important one, probably the safety glasses, probably the torque wrench, probably the end of session cleanup, just one. Do it consistently for 30 days, not because you remember. Set a physical reminder. Glasses on the bench, not the shelf. Wrench on the hook beside the car, not in the drawer. Do the one thing until you don't have to decide to do it anymore, then add another. This is not about making your garage look good. It's about raising the standard of what comes out of your garage. The work you do reflects the environment and the process you do it in. A garage with a system produces consistent, reliable, high-quality results. A garage without one produces results that vary with the mood of the afternoon. That's number one, not a tool, a standard. Set one, raise it, everything else follows. 30 tells. From the plastic cases to the standard you keep. How many are in your garage right now? Be honest, not with me, with yourself. Pick the one that bothers you most. Fix it this weekend. One fix, then another. I've got a video on 25 tools that expose amateur garages from the equipment side. What you own versus what you should own. Different angle, same theme. It's on the screen right now.